Hello and welcome back to our channel. And we continue our discussion with the circuit analysis and design, especially the analog circuits. And here on your screen, we see a network that consists of, let's say, what we have is the current source of 1 milliampere, the voltage source of 5 volt, and the 2K resistance each. And we are asked to calculate this current I into the network. So by simply analyzing this circuit, we got to understand how we can solve this problem. So we can apply the superposition law. So for that, we say we want to know the value of the current I. So we will say apply superposition law. Superposition law says this is in a linear network with multiple sources, whether current and voltage sources. We can compute or calculate the value of any current or voltage by making one source active at a time while making all other sources inactive. So for example, I will make sure first analysis, 5 volt is active in the circuit while the current source is inactive. And then I will calculate the value of I. We will call it, let's say, I1. This I will be then I1. In the second case, I will make sure the current source is active into the circuit and 5 volt DC voltage source is inactive in the circuit. So with that, I will compute or calculate the value of I. I will call it as I2. And then to get the total value of I due to both voltage and the current source being present in the circuit, I will sum the calculated values of I1 and I2. And that will be the current I due to this two sources active in the circuits. So that's what superposition law says. So first thing, let's say the case one, the first case, I am making sure that I have only 5 volt voltage source, and then I have this 2 kilo ohm resistance. I have another 2 kilo ohm resistance, and here is also 2 kilo ohm resistance, and this current source is open circuited. So you see that you have like this is your ground and this is your open. So obviously there is no current in this loop. This I here is equal to 0. Let's say call it Ix. However, you have got this current I that needs to be calculated. So what you can see, this I is nothing but here that is flowing here. So let's call it like I1 now, which is I. This is I right here will be 5 volt divided by 2 kilo ohm plus 2 kilo ohm. These two resistors are in series. So that is 2 plus 2 K. So it is like 5 divided by 4 kilo ohm. So 1.25 milliampere is the current due to only 5 volt DC voltage source active in the circuit. So that is your first value of the current I. Now, in the second case, we can draw the circuit. For example, here, this voltage source is removed. It means there is no voltage. So V is equal to 0 here. However, I have this 2 kilo ohm. Then I have this 2 kilo ohm again present here. And I have this 2 kilo here ohm. And now the current source of 1 milliampere, remember 1 milliampere is 10 to the power minus 3 ampere, is active in the circuit. And this is your ground. So now this current, this current is flowing through this resistor right here, and it gets splitted into these two parts. So obviously we want to know the current flowing through this resistor 2K from this direction actually. And so this current in this direction is nothing but this current in the opposite direction. Okay, so we'll just have to change the sign. So how to do that? So I know that the current here is 1 milliampere, which is splitting between the two equal values of the 2 kilo ohm. So obviously the current through this resistor will be 2 kilo ohm multiplied by 1 milliampere divided by 4 kilo ohm. So simple current division law right here. Okay, and that comes out to be 2 divided by 4, and well, that is like 2 milli, uh 2 divided by 4k, so it is like zero point 0.5 milliampere. Okay, now the direction of this current is like 0.5 milliampere, so which is flowing right here. Okay, let me show you through this pencil. Okay, through the different color. So obviously we want to know this way, so obviously we'll put the minus sign here. Okay, so with that said, your second value of the current due to which is I2 is also calculated, and therefore the total current due to both DC voltage source and the DC current source present in the circuits will be the sum of I1 plus I2 will be like 1.25 milliampere, which is this current, minus, or simply say plus, and this is your minus zero point 0.5 milliampere that you got here. Okay, because it's in the other direction, so it will be like 0.75 milliampere. So that's your current, 0.7 milliampere current that is flowing right here. This is the answer. So hope you understood this concept of superposition. And if you like the video, click the like button, subscribe to our channel, share this with others for wider reach. Stay tuned for more engaging contents like this. Till then, wish you happy learning.